Hello, this is a demonstration of OpenWire Studio, new software application from Mitov Software. OpenWire Studio is a standalone development and execution environment for building complex signal, video, and audio processing applications. For this first demo, I'm going to build an application to do some simple transforms and analysis on a video file. So let me get started with an AVI player. I'll come over to the component palette here on the right. In the edit box, I'll type AVI to filter down to AVI related components and then drag the AVI player onto the OpenWire editor. I'm going to set a couple properties. First, I'm going to set the loop to true. Over here in the property inspector, you see loop. Currently it's false. I'll click to make it true. Then I'm going to set the file name. I could do it here, but a quicker way when you're working in the component editor, or excuse me, in the OpenWire editor, is to click on this tool icon and up pops the file selector. Okay, so we've set the file and loop to true, and now we need an image display component, and we're going to connect the video output pin of the player to the input pin of the display. Now when I hover over the video output pin, notice that the compatible input pin is highlighted. That happens each time you hover over an output pin. So let me click, release, and then drag the wire to the destination pin, click again to connect. Okay, we have an application here to play video. Okay, you see it plays the video there. Now let's add our transformation. I'm going to add another image display for the video swirl effect, and now I need to find the swirl component, so I'll type in swirl, drag this component over here, and we need to connect the video output pin to the input pin of the swirl filter, and then the swirl's output to the image display's input. And let's see the results. There's our swirl effect. Okay. So that was a transformation. Now I'm going to do a quick analysis. We'll look at the RGB color values of that video stream. To do that, we'll use a histogram. And we're going to feed the output of the histogram into a scope component. We have red, green, and blue pins here. Notice there's only one input channel on the scope. To get more, we'll double click, and up pops the pin editor. We'll click the plus icon to add two more channels. And now we have channel 0, 1, and 2 there on the input pins. We'll connect red, green, and blue to channels 0, 1, 2 respectively. And now we need to connect the video to the input of the histogram. So we'll go back to our video output pin. And let's check out the results. So you see there we're displaying the red, green, and blue histogram values on the scope from the video stream. Now we'll take a look at the audio. We'll do some more analysis. We'll do a Fourier transform on the audio output. Notice there is a video output and an audio output pin on the video player. Let's find our histogram. Oh, excuse me. Fourier, sorry. Fourier transform. We already did the histogram. And we're going to connect the audio output to that Fourier transform. So now we're feeding audio into the FFT component. Let's set the order of the FFT while we're at it to 8 and ignore DC. And we're going to feed the Fourier output, the spectrum output pin, into a waterfall display. Okay, the spectrum output pin goes to the input pin of the waterfall. Okay, let's see how that looks. Okay, you see the audio trace over time there on the waterfall, and our other swirl and RGB effects there. Now let's take a look at the level of the volume level of the audio. Let's get a ppm meter. Let's put it here. Feed the audio into it. So that converts our audio buffer stream values, multiple values, into a level, ppm level. And we're going to feed one of those output channels, left or right, pin 0 is left. We'll feed that into an angular gauge. Here's our ppm meter, and we'll connect that to the angular gauge. Now let's run. Okay, we have all of our other displays that we built previously, and now the angular gauge is reflecting the audio volume. Now let's hear the audio. We can see it. Let's hear it. We'll find an audio out component. We can put it anywhere. It's a non-visual component. Let's put it up here, and we'll connect the audio pin, the output pin, to the input of the audio out component, i.e. a speaker. Now we should hear the audio when we play the application.
Cena gets a second chance at a peaceful life on an all-new episode.
Okay, so we have audio there. Now I don't want the audio playing as I try to talk through the rest of this demo, so I want to undo that last step. I want to undo that audio connection. So I'll go up here to the audio, or excuse me, to the undo list, and I could just click the undo button. It would undo that last connection. Or I can look at the entire tree of steps. 2 components moved, and so on. Move, 3 components created, connect. So I can find any step in my history, my stack of undo commands, and revert to that state. But right now we'll just click the undo to disconnect the audio. We'll go ahead and leave the audio component on there. It won't hurt. The audio out, and now we won't hear it. Okay. So that's the building and running mode. There's also a Visual Live Debug mode with OpenWire Studio. So far I've been clicking this green run button. If I click the green debug button, it runs in the OpenWire editor canvas. You can see the application running here, and I can edit it while this is happening. For instance, let me redo that audio out connection. Notice it connected the audio out component.
Cena gets a second chance at a peaceful life
Now let me,
on an all-new episode.
And I undid it to disconnect it. So I can add components, remove components, add, remove connections while I'm debugging. In addition, we have the ability to see what's flowing through each wire. For instance, let's look at what's coming out of the ppm meter down here. When I hover the mouse over the PPM wire, we see values, 3,000, 5,000, 7,000, basically the numerical values of the audio buffer. Let's look at what's going into the audio, to the PPM meter. There we see the left and right channels of the audio stream. Let's look at the output of the FFT. There's the spectrum of the left channel on the audio. Now let's take a look at the video stream. There's our video, and if we look on the output pin of the swirl, we see the swirl coming out of that swirl filter. So we can examine any stream with this visual debugging, whether or not that is connected to a visual display component. We simply hover the mouse cursor over a wire. That concludes this demo. We'll make some more demos. There are many other features of OpenWire Studio, and be sure and take a look at the remaining demo videos to see what else OpenWire Studio has to offer. Thank you.